Assalamu alaikum, young researchers and students. My name is Bekzod Aminov, and I study at Tashkent State University of Economics in the major of World Economy and International Economic Relations. In this video, I'm gonna do a research on the country I've been given in academic skills lesson. Here's 20 conditions that my research must contain, and I'll do it one by one in this video. I'm going to start with first one, which is country World Bank Open Data Profile Excel file. Okay, how do we do that? We should go to browser we use in our computer, and we will search World Bank Open Data. And we will open this first site that appears on our screen. Well, we can browse by country or indicator. I am browsing by country, and we will go to E because my country is Italy. Here's Italy. Here's all the information which belongs to Italy. Okay, we can download it in Excel file. We downloaded it. Okay, so we can consider the first one as done. So I will be marking it as green, which means it's done. We will go to the next one, which is importing Excel file into Stata and save it as DTA file. Well, how do we do that? In order to do that, we will go to our browser, which we have downloaded Excel file from World Bank Open Data, and we will open it gladly. Well, and we will give permission for editing. Okay, in the bottom, you can see the three sections, which are data, metadata countries, metadata indicators. We don't need metadata countries or metadata indicators, we only need data. Okay, here is all the information about Italy from 1960 to 2023. So I would like to mark the row which shows years, and we have to copy it and open a new Excel file, blank Excel file, and we can pass it here by clicking the right bottom of our mouse using the force paste option. Well, we'll go back to our Excel file in order to find variables which we will be using for our research. Well, here are the information about Italy, and you can use them as variable in your research. You can use, income share by holders, price level ratio of PPP conversation factor, or GDP per capita or anything like that. Any of them you can use as variable. Okay. I would like to choose the random of them in order to show you how to pass it. We can use the same technique to pass it by clicking on the right side of our mouse and choosing the force passed option. Well, we don't need the first one, we can delete it, and we don't need second one as well, and we will delete this one as well because we don't need it. We do not need it. Okay, I've made that Excel file beforehand, so I'm gonna be using it. So I've saved it. It's Italy on my desktop. I will opening it. I will be opening it right now. Okay. Okay. Here is my Excel file. I've chosen as variables GDP, population, military expenditure, inflation, import goods, export goods, unemployment, manufacturing, and GDP per capita. And I will be using these variables in my research on Italy. Well, we will close it right now. We have to save it first because we can lose our information. And we will go to Stata app. We'll open the Stata app. We'll go to File. We will import the Excel spreadsheet. So import browse. We'll go to the exact location which we have saved our Excel file. So it's my Excel file, and you know that here you can see the informations statistics, and the data is treating the first row as a statistic or information. Uh, Actually, these are the variable names, so we have to import the first row as variable names. And okay, well, everything is fine, and but just in case we have to check if everything is fine, we can use the command br. Well, here is it. Uh, I think something is wrong because you can see the informations under the variable name here is in red color, which means something is wrong. Uh, I think that happens when the statistics is in string format, not in numeric format, and we have to convert it from numeric from string to numeric. And for that, data create or change data, other variable transformation commands, and convert variable from string to numeric. Well, we choose here, and we have to choose another name for that. I have chosen years. Well, you can see one more variable appeared here, and we have to delete one of them. We have to drop one of them, and I will be dropping year and name year, label year, because it had problem, and we have to drop it because we have created a new variable which has no problem. Okay, yes. One more time, check it, BR. And here everything is fine, and we have to save it. I will be saving it, save as, in my desktop, and I will be using this name, Italy, D, DTA file, Italy DTA. Okay, let's save it. Well, I think the second one is done as well. We will mark it as green. Uh, and now it's done. Well, we will go on to do the third one, which is making do and log file. Well, making do and log file takes considerable time, which is why I made them beforehand before recording this video. Here you can see my log file and do file. I will open them one by one. The log file contains all the history of you using commands using do file and Stata. Here is my log file. Well, and I will open the do file now. Here's my do file, which I've saved all the commands I will be using for my research in here, and I will show you one by one using them instead of writing them every time. I've saved them in one file. Whenever I need them, I can use it. I can use it. That's like my warehouse. And how can we do a new log file and new do file? Well, in order to make a new do file, you can go to that section and you can choose new do file editor. You can write your own do file in here using comments which you will be using in your research. And in order to make a log file, you have to click this one and you have to save it before writing your log file. I can save it in my C disk, like Italy log file. Well, and as you start writing comments using comments, it will appear here like I will use verb manage, for example. It's right now showing nothing, but if we just close this window and go to that section. Italy log. It's showing var manage, right? It's showing the command of var manage, which means it's saving every single commands we are using in log file. Well, we can consider as ZERT1 as done as well. So I will be marking it as green. Well, let's go on to complete the task 4 and task 5. I would like to complete them simultaneously because they should be done in one way. The first of all, we have to make analysis relating to our research. That includes finding relationship, finding slave regression, and post estimations. And then we will interpret that analysis in words. Well, let's go then. Well, we'll open this data file we have saved previously, and we will open the do file from here. And these are the commands which we have saved previously. So we'll give this one by one, and we have to install this asset first of all. Well, checking asset consistency verifying already installed. Okay, and we will see it. Well, here is the table, the first table. Here is the first table. I've made it before so many times, so I will be just copying it. I will copy it and paste it in my word interpretation. Well, this is the first table, and in the first column, as you can see, it's showing the variable names here, GDP, population, etc. And the second column is showing the observations. Some of them have the 64 years of observation, while some of them have only 54 or less, 34, like manufacturing. Mean means the average value for each variable. For example, the year value includes the information from 1960 to 2023, and the mean value is 1991.5. Standard deviation means how much it varies from mean, and the minimum and maximum shows the range of our data. And the minimum is showing the lowest point, while the maximum is showing the highest point. Well, we will get back to our data. Well, we will use that command because we have to specify the years which we will be using in our data. Well, time variable year from 1960 to 2023 delta 1 unit. Well, we will draw the graphs one by one, and the first graph we will be drawing is TS line. Well, this is a TS line, and this TS line is showing the relationship between manufacturing and years, and we can say like it's showing the Italy's manufacturing over 34 years. And here you can see the Italy's manufacturing, and it's showing some fluctuations over the years, but if we look at it from overall point of view, we can see growth, right? It has it has demonstrated some growth uh, substantially, even though there are some fluctuations over the years in Italy's manufacturing. And we will copy it and we will pass it in our Word file. TS line graph. Okay, graph displays a trend of Italy's manufacturing output from 1960 to 2023. It's made a mistake. I think I made a mistake. Okay, showing values ranging from approximately 2e plus 11 to 4 E plus 11 time series line indicates fluctuations and growth in manufacturing production over years. Overall upward trends reflects the sector's expansion. Okay, overall upward trend. Let's highlight this section because it's showing the upward trend from overall point of view, as I have stated earlier. Well, uh, let's see Italy's manufacturing, Italy's export goods over the years. Well, this is showing steady growth, but between 2005 approximate numbers and until 2020, we can see downward trend and some fluctuations in Italy's export goods, but after 2020, it's showing steady growth. Well, from overall point of view, it has shown considerable amount of growth. Well, here is it. Okay, we will make it 2023 here too. Okay, timelines indicate steady growth and GDP over decades reflecting economic expansion and development. Okay, upward trends. It's showing the upward trend highlight the country's increasing economic output and overall progress. Okay, let's go on to third one. Italy GDP over years. Well, it's also showing steady growth, but as I have mentioned, it's in export goods between 2005 and 2020. It's showing some fluctuation. I think that's because of export goods of Italy, and because they have positive correlation and they have positive connection between them. As one decreases, the second one decreases too. So they are showing the same result between 2005 and 2020. And we will copy it as well. Put it here. I've already passed it here before. 2023. Okay. Consistent growth. It's showing consistent growth well in GDP over decades, reflecting Italy's economic expansion and development. It's also showing the upward trends. I think it deserves to highlight. Well, and let's use the next command here. Okay, graph combine. This command helps you to combine all the three graphs which you have drawn earlier, and it will draw it in one frame, which allow you to see all of them simultaneously. Well, let's go on to draw scatter plots. Well, this is the first one, and this scatter plot is showing relationship between export goods and manufacturing. Well, we can see dots here, and they are showing the relationship of these two variables, and they are going upward. As you can see, it's going upward, and which means manufacturing and export goods have positive correlations. What does it mean? The positive correlation mean as one variable increases, the second one increases too. If manufacturing increases, the number of export goods increases too. While if manufacturing goes down, export goods, the same will happen with export goods too. Well, we will copy it and pass it in our well, this is scatter plot. Okay. Okay. Notable growth and variability reflecting chains. Okay, I've seen it before. And let's see relations between export goods and GDP per capita. Well, export goods and GDP per capita is showing steady growth, right? They have a positive correlation too, and I have stated that just before on this one. not on this one, but in TS line graphs, by connecting expert goods in GDP. Well, they have positive correlation because that's are going up, and which means if the GDP per capita goes down in Italy, that will affect export goods too, and it will go down as well. Well, I don't think we should see it because we have seen it in this line. The this line expert goods, and it's showing the same thing as scatter. So I don't think there is need for drawing that graph. Well, let's draw another graphs. Well, uh, this graph is almost same as scatter plots, but the only difference is the red line you can see between these dots. This line is providing evidence to us that the dots are indeed going up, and which shows the positive correlation between export goods and manufacturing. Well, well, here is it. Okay. Uh, Scatter plot displays individual data points while fitted line indicates the positive relationship. The fitted line is that red line between these dots. As manufacturing increases, good exports also tend to rise. Okay, this suggests that higher manufacturing production is closely linked to increased export activity. Well, let's say we have to draw the next line. Well, if we have understood that graph, well, what is it showing? It's showing the export goods of Italy over the 54 years, and we have seen it earlier, and I've said that uh, that's are going up, and that line is providing evidence for us to see it. Well, okay. The scatter plot displays data points and shifted line real positive relationship. As good exports grow, GDP per capita also increases. I think that's worth noting. Okay, what about GDP per capita in export goods? We have seen it before, and this line is showing, the proving that relationship is positive as the this line is going up. There's it. Export goods and GDP per capita. Okay. The fitted line shows the positive trend. Higher good exports are associated with increased GDP per capita. Okay, this suggests that greater export activity fosters economic growth and higher standard of living. Okay, highlighting the significance of international trade in strengthening the Italy's economic performance. Well, what about inflation in export goods? Well, unlike other scatter plots, it's showing negative relationship between inflation and export goods. If inflation increases in Italy, it will demonstrate negative impact on export goods of Italy, which leads to decrease in the number of export goods. As you know, If export goods increases, and it will have negative impact in inflation, and they will have negative correlation. They have a negative correlation. Well, here's it. Okay. The fitted line indicates a weak or unclear relationship. As goods exports increase, inflation doesn't show a consistent trend. Okay, and this suggests that export activity might not have strong direct impact on inflation rates. Well, well, let's go on. Okay, let's go on with person correlation tests. Well, the, and this is the person correlation test, and it's showing the relationship between variables. And I would like you to focus on the first column because it's showing the relationship between export goods and other variables such as year, GDP, population, military expenditure, unemployment, and manufacturing. So, before we interpret that, just let's take a picture of it and put it to my words. Well, here is it. Okay, and the expert goods is showing a strong positive correlation with variables. Like it's showing good correlation with year, GDP, population, military expenditure, and manufacturing because the least amount is 88%, while it has weaker connection with unemployment with only 28%, which means the expert goods doesn't have any direct impact on employment. Uh, okay, well, and let me interpret you in more detail. This table is showing that this is showing the percent of their connection, and this one is p-value, and most of them has zero p-value, and while and this one is that this one has different value. But if you look at it from overall point of view, all of them are statistically significant because the p-value is less than 5%, which makes them statistically significant. And the third row is showing the number of observations. And let's go on with experiment test. Well, this is the experiment task, and let's take a picture of it and pass it in my Word file. Well, here is it. Okay. Uh, the expert goods column in the experiment correlation results indicates a strong positive relationship with the year, suggesting that expert goods have increased over time. uh, you know, we cannot just talk about experts goods and expert goods because it's showing the 100% they are kind of alike, and also we should only focus on the first column because my research is on expert goods, not on other variables. I need other variables for doing the research. Uh, okay. And then 92% of positive correlation with year of export goods suggests that export goods have increased over time. GDP, the 73% showing that the higher GDP is associated with greater exports. Population, with 82% indicating that countries with larger population tend to have higher exports. Okay, military expenditure with 80% implying a link between experts in defense spending. Defense spending is military expenditure. Okay. Manufacturing with 86 reinforcing the relationship between industrial production exports and GDP per capita, suggesting that wealthier nations tend to have higher exports. Okay, uh, the export goods has only negative connection with inflation export goods, which means the inflation in employment doesn't have any impact on export goods or negative impact. They have a negative correlation. Like if inflation increases, export goods decreases. If unemployment increases, uh, exports increases, just like that. Okay. As we can see here, meaning that higher inflation is associated with lower exports, unemployment indicating that higher exports might be linked to lower unemployment levels. Well, I think that's fair. Uh, well, let's go on with other ones. Hmm. Okay. What about this one? This is one type of graph as well. Okay. What does this graph shows? It shows if the one variable is normally distributed or not. The closer the dots are to the line in the graph, the more normal the variable is distributed in country. Well, in here we can see it's not perfectly distributed. It's not normally distributed from overall point of view because the dots are not near the line. Well, this is one example of it. Let's say the manufacturing and manufacturing. Well, it's almost normal distributed, but not perfectly. There are some deviations from the line, so we cannot even conclude that it's perfectly distributed, but almost normally distributed. Well, we will put that on our Word file too. Well, where is it? Okay. Let's just read the interpretation. Okay. I will highlight the most important parts. Okay. The variable follows an approximately normal distribution. There are some minor deviations. There are some minor deviations indeed. Uh, okay. They are not substantial enough to suggest severe departures from normality. Okay. There are some deviations, but they are not so severe, which is why we can conclude that it's normally distributed. Okay, my time is limited, so I would like to. I have a lot to say, so I will just give you an example of each one by one. Okay, and the next graph which we'll be drawing is histogram. Okay, let's say we see expert goods and the one we are doing a research on. Well, you know, what this graph shows. The first of all, it shows the density of expert goods. We can see the highest point is here around 0. Well, it will be better if we just take a photo of it and put it. You will understand it better in my words because I have interpretation in there. Well, here's it. The histogram shows the distribution of expert goods values. Distribution is uneven with peaks at lower and middle values. Okay, suggesting the variability in export data. Well, it showed that in Italy's exports have been different over the 64 years. Okay, density curve indicates the possible multimodal distribution, meaning that exports might not follow single trend but rather fluctuate across different levels. Okay, just we have to note that the multimodal distribution means experts might not follow the variable might not follow a single trend but rather fluctuate across different levels. Well, let's go on to the next one. We will see graph box, shall we? Okay. Well, this one is showing that the graph box and this line in between is median, and this shows that the half of the data is below that level, the half of the data is above that level, and that box shows the 50% of information, while this one shows the 25%, and this one shows the 25% of the data. Uh, the data. Well, this shows the peak points. Peak points. Well, let's just take it into our. Okay. Okay. The plot shows the distribution of Italy's export goods with 50% of values ranging approximately between this and this 6 times 10, 11, 10, and the median expert's value is around this section. From that, it's located in the middle of 4 and 2, and we can conclude that it's in the middle, and it must be 3, right? The half of the experts are below this level. Half of the experts are below this level. Okay, the whiskers extend from nearly 0 to this part representing full range of expert values. This suggests moderate variability and expert Italy's experts influenced by key industries like manufacturing and luxury goods. Okay. Um, well, that's all. Let me see. Swilk test, right? Shapiro Wilk test. We will go to Stata, and the Shapiro Wilk test. What does this test? Well, it shows if the variable is normally distributed or not, and we have O and HA. Uh, we have HO and HA, and we can conclude that the manufacturing is normally distributed, while export goods and GDP per capita is not. Well, let's take a picture of it and make sure that you understand well how the Shapiro book test works. Well, here, Shapiro-Wilk test. Okay, Shapiro-Wilk test results indicate that manufacturing data does not significantly deviate from normality, while export goods and GDP per capita show strong evidence against normality, suggesting they are not normally distributed well. Uh, we have HO and HA hypothesis, as I have mentioned before. We reject HO means the HO means that our it's normal distributed, while the HA suggests that it's not normal distributed. And how do we know that when to reject HO and when to reject HA? Well, if the p-value is less than 0.05, it means that it's statistically significant, and we can reject that it's not normal, and we just reject HO. Uh, if the p-value is more than 0.05, which means we reject HA and accept HO, and it means that our data is normal distributed. So which is why in the end you can see the 0 0.3 0.3 is more than 0.05, which is why we are concluding that the manufacturing is normal distributed, while export goods and GDP per capita p-values are less than 0.05, which is why we are suggesting that they are not normally distributed. Well, let's go on with the next test. Well, the next test is linear regression test or Stata. Okay. Well, what does it show? Let's just take a picture of it and pass it um, in my Word file, and I will interpret there because it's will be much more comfortable for you. You can read the interpretation yourself. Well, here is it. The regression model explains the 97.94% of variation in expert goods. Well, R squared, R squared thing uh, is equal to indicating a strong fit. The year variable has significant positive effect on experts. Okay, which means that experts has increased over time. Well, we have tested that theory before, and in many tests that over the years that expert goods has increased. And the manufacturing has also positive and significant impact. And how do we know that it's significant? Because you can see the p-value here. The p-value is less than 0.05, which is why we are stating that our statistics, our data is statistically significant, and it has significant and positive impact. Okay, meaning the higher manufacturing output is associated with higher exports. That's indeed true. We have tested in our previous test. GDP per capita appears to have big insignificant impact. Well, the test is saying that it has insignificant impact on export goods. Well, because the p-value is more than 0.05, which is why we are saying that it has insignificant impact and it has weak impact. Well, let's go on with the uh, next test. Well, what about robust regression? Well, this is robust regression, and it's actually saying the same thing, but it's actually the same thing, but let me interpret to you. Okay, the model shows that export goods are strongly influenced by time, with a significant upward trend over the years. Manufacturing has a positive and meaningful impact, suggesting that, okay, uh, manufacturing has positive and meaningful impact. Let's highlight this section. Higher production levels contribute to increased exports. Well, we have stated that fact clearly. GDP does not have a strong impact on export, while imported goods show significant negative relationship, indicating that higher imports are associated with lower impact. In previous tests, we have tested only three variables, and I wanted to add one more, which is the import goods. Okay. Import goods shows significant negative relationship, indicating that the higher imports are associated with lower exports. Well, okay. The model explains the 99.0101 of the variances in export goods, making it highly predictive. Well, um, it has negative relationship, but it's significant, which is why we are saying that the higher input goods is associated with the lower exports. Well, let's check the other ones too. Well, we'll go to this section. Well, I think I would like to check this one. My time is limited, so in this one, well, well, what it's showing. Well, our results, the mean VIP must be below 10. We have to take away some variables here. And what if I just, you know, in order to do that, we'll just copy it and just we'll change some of the variables. GDP per capita, GDP, manufacturing. We will add what about the population and robust, and we'll use that command one more time. So, well, this is my asset VIV, year population, GDP, and manufacturing, and the mean VIV is equal to 4.28, which is very normal for our situation. Well, we just take the photo of it and take it to my Word file. Well, here's it. The wave values indicate no similar multicollinearity. That this table shows the, it's used this is used to check the multicollinearity with mean of VIV 4.74. Okay, um, 74 show moderate multicollinearity. I cannot specify it properly, so I'm sorry. You can read it here. Okay, okay. In economic analysis, the multicollinearity matters because it can inflate standard errors, making it harder to determine the true effect of each variable. Well, for instance, military and manufacturing are highly correlated. It might be very difficult to isolate their impacts on economic outcomes like GDP or trade. Addressing multicollinearity ensures more reliable policy recommendations and economic forecasts. Well, I wanted you to know what multicollinearity means and why is it important in economic analysis. So I added that interpretation. I hope it will be useful for you. Well, let's go on. We have ANOVA test. Um, well, okay, and we have this. Mhm. Let's go to Word file, and here's our file. The graph shows the distribution of linear prediction from the regression model. The uneven spreads of bars suggest deviation from normality, indicating potential irregularities in model's prediction. Specifically, the clustering of values and gaps between bars imply that residential residuals may not be normally distributed, which will affect the reliability of statistical inferences. This deviation is further supported by non-smooth shape of density curve, highlighting inconsistencies in model's predictive performance. Well, let's see the box graph. Whereas the graph box, this box shows that your linear predictions are mostly clustered between roughly 3 times 10 times 11, the 6 times 10 times 11, with the middle value median around this part. Okay, this suggests that the data below this median is 50% and the data above that line is 50% too, which is the definition of median. It's located in the very middle of it, and that box includes the 50% of the information. Okay, the spread of data is relatively wide around all visual liners. Okay, and we'll do that test. Well, I've already transferred it to my Word file. Here is it. The state output shows the predicted value from linear regression model with values decreasing from 8 point e plus 11 to 8.0 e plus 11. This indicates the downward trend independent variable as the independent variable increases. Well, let's highlight this, reflecting a significant negative relationship in the model. Well, okay. Okay, my time is limited and the video time is gonna exceed more than an hour, so I'm gonna make it a little shorter and I'm gonna show you not all the comments here, so I will be just showing some of the graphs. I will interpret them. Well, we'll copy it here. This is not the completed version of my Word file, so I can just make sure that well, here is my completed Word file, and I have all the informations here, and I will send you this, and you can have access to that file, and you can understand all the commands I've used in Stata with you know the interpretation below. I've tried to give as detailed information as possible, so my time is limited, so I'd like to leave it to you to understand that sections. If you have any questions, I will leave my number under the video and you can call me anytime you want. I will be glad to help you. Well, let's just put ticks here. I will mark them green, so it means that it's done. And so this works is done.